When we think about AI projects, it's easy to imagine a clean, step-by-step process. Define a goal, collect the data, build a model, and deploy it. But the reality is far less linear, and far more alive. Managing AI is not about building once and deploying forever. It's about experimenting constantly. It's about asking better questions, discovering uncomfortable truths, and learning our way to the right solution. Each stage of an AI project introduces a new kind of uncertainty, and with it, a new kind of experiment. Here's how that looks, across the full lifecycle. 1. Business hypothesis experiments. What if AI could help? The journey starts not with algorithms, but with assumptions. A business team might believe that reducing claim review time by 40% will improve customer satisfaction. Or that automating document classification will slash manual overhead without affecting quality. But these are just hypotheses, and they must be tested. This stage is filled with early conversations, ROI simulations, and what-if modeling. You test whether the problem is real, urgent, and solvable, and whether AI is the right tool for the job. Here, failure is cheap. And clarity is gold. 2. Data discovery experiments. Do we even have the right data? With a clear business goal in sight, the next experiment dives into the messy world of data. You ask, is the data available, accessible, accurate? Is it even the right data? You begin profiling. You check for missing values, anomalies, strange patterns. You visualize distributions. You find that fraud data behaves differently across regions, or that customer churn labels are inconsistent across systems. This is not about cleaning yet, it's about understanding. And sometimes, the biggest insight is that the data you need doesn't exist. Or worse, it exists, but it lies. 3. Feature and signal testing. What variables actually matter? Now we get to the signal. In this phase, you try to understand which features move the needle. You ask questions like, does customer tenure correlate with churn? Is raw age useful, or should we group into age buckets? What happens when we add geographic data? Or strip it away? It's part science, part art. You create, transform, discard. You test features one by one and in combinations. Because every good model is built on strong features, and every bad one is a warning missed in this phase. 4. Algorithmic and model experiments. Which model fits the truth best? This is the lab. Data scientists try a decision tree, then XGBoost. They tune hyperparameters. They split the data differently. They compare performance across folds. They argue over the meaning of a 0.76 F1 score versus a 0.82 precision. But here's the trick, they're not just chasing accuracy. They're looking for robustness. For fairness. For speed. For something that performs well and explains itself. This phase is where the math breathes. But it only works if everything before it, the hypothesis, the data, the features, was done with care. 5. Evaluation and bias experiments. Can we trust what we've built? A model can be accurate and still wrong. So now you evaluate it from every angle. You test it with new data. You simulate rare scenarios. You ask, is it treating all demographic groups fairly? If the data shifts tomorrow, will it still perform? You use tools like SHAP and LIME to make the model explainable. You sit with legal and ask, could we explain this to a regulator? Could we defend it in court? You look for bias. For blind spots. For anything that might break trust. Because once a model is live, the cost of ignorance skyrockets. 6. Integration and performance experiments. Will it survive production? Even the best model in a Jupyter notebook is useless if it crashes in the real world. So you simulate deployment. You run A/B tests. You stress test latency under heavy load. You monitor for feedback loop instability. You check how it performs during a system outage or when someone fat fingers a field. You ask, What happens when 10,000 users hit this in real time? Can we trace an error? Can we roll it back? This is the phase where AI stops being a research project and starts becoming a product. 7. User adoption experiments. Will people use it and trust it? Finally, we test the most human part of all, adoption. We ask, do people understand what the AI is saying? Do they trust the recommendations? Is the interface clear? Does it answer their real question, not just the technical one? Sometimes, a model is right, but the output is misunderstood or ignored. So we pilot it with users. We gather feedback. We iterate the UX, the dashboard, the explanation layer. Because in the end, if no one uses it, it doesn't matter how good it is. Final thought. AI is a series of experiments. An AI project is not a build. It's a living series of experiments, each designed to test a piece of the unknown. You're not optimizing for certainty. You're learning your way to impact. So embrace the experiment. Celebrate the failure that teaches faster. Design for discovery. In AI, success doesn't come from being right the first time. It comes from being curious enough and rigorous enough to fail better until you find what works.